So the first thing is, what is a quadratic function? Well, if something is quadratic, and you might remember from grade 10, that means it is a polynomial of degree 2. And if you remember, degree just means what the power is, or what the exponent is. We're going to look at polynomials at great length, of higher degree, later on, but right now we're just looking for quadratics, something of degree 2. So the general form of a quadratic is this thing right here. F of x equals ax squared plus bx plus c. So it's this squared value that denotes that this function is a quadratic function. So there's just a little bit down here we have to make sure of. This says where a, b, and c are real numbers, so they're just any number that are allowed, and a cannot equal 0. So if we imagine for a second what would happen if a was 0, our quadratic would disappear, our squared would disappear, and we would just have a linear function. So the next thing we're going to look at is graphing a quadratic function. Now we looked at different types of functions on their graphs in chapter 2. Now we're going to look at the graph of this quadratic function. So what we're going to do to start is we're just going to graph this quadratic function, y equals x squared, and I'm just going to do it with a table of values. So we're just going to create ourselves a table of values to graph this quadratic function. Now, when you're making a table of values, you can pick whatever values you like. So let's pick ones that make the math easy. So values for x and what we're going to get for y. So I'm going to pick -2, -1, 0, 1, 2. And if those are the values that I picked for my quadratic function, or for my quadratic, the values for y, if we put -2 in there, -2 squared gives us 4, 1 squared gives you 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So we have a quadratic that looks, those are the values. So now we go to our graph and we can plot our points. And we want to be careful when we plot our points to make sure we're getting these points correct. And so we're just putting in our values from our table of values. And with a graph, we want to just connect those dots as best we can with a function that looks like so. So there is our graph of y equals x squared. Now, this graph and this shape is got a special name. This is a parabola. So that U shape is what we call a parabola. So that's the first thing about quadratic functions, is a quadratic function will always give you a parabola. It'll always give you this shape, this U shape. Now there's another thing about quadratics, something unique, is if we were to draw a line right down the middle, and it's probably a little more obvious on your graph than it is on my graph, but this line right here, this is like it's a mirror image. If we look on this line, the same thing appears on both sides of the line. So we have this U shape on one side, and on the other side we have the exact same shape. That's what we call symmetric. Yeah, hopefully you've heard that word before, but in terms of math that's called symmetric, meaning it's the exact same thing on both sides of the line. This line is then called the axis of symmetry. And that's going to be very important in quadratics. So the axis of symmetry. And in this case, the equation of this axis of symmetry is just x equals 0. So right down the middle we have this axis of symmetry. Now that's a very, very basic form of a quadratic. Let's look at something a little more complicated. So let's take and compare our original graph to the graph y equals -x squared. So what I'm going to do is I'm going to first put in the original graph. What I'm going to do is go back to black here, and I'm going to put in those points. Now if you have to, take a look back and make sure you have those coordinates right, and we're going to plot our original parabola. And what I'm going to do, after I have my original, is I'm going to do myself another table of values, and I'm going to plot y equals negative x squared. Yeah, now what I'm going to do is I'm actually going to use the same values that I used before for x, and this time we're using this equation, y equals negative x squared. We're going to use the same point, so negative 2, negative 1, 0, 1, and 2. So what happens? Now what I'm going to do is I'm just going to show you the first one, because if we put negative 2 in here, that negative on the original function stays outside of the brackets, meaning we're putting negative 2 in for x. So what that means is we're going to get negative 4. So negative 2 squared is going to be negative 4. Negative 1 is going to be negative 1. 0 is going to be 0. 1 is going to be negative 1. And 2 is going to be negative 4. It's the exact same thing we did before, except now if I plot this, and I'm going to plot this in a different color just so we can see, is that when I go to negative 2, I'm down here at negative 4. And negative 1, 0, 0 is the same point, negative 1, 1, negative 1, and 2, negative 4. So what do I have? I have that same parabola. We have that same parabola, but now what happens is it's been flipped over. Now we don't like to use the word flipped over in math, but what's happened to this? This has been reflected. Basically what's happened is our parabola, which was pointing up, has now been reflected across the x-axis, and now it's upside down. And that's all we have. So what we have here is we have a reflection across the x-axis. Now, the only thing that's different between the two original equations is one's positive, one's negative. It's the only thing that's different. So, of course, what we can conclude is this negative sign causes this reflection. And that's the first property of quadratics, is if there's a negative in front of the value, we have a reflection across the x-axis.